In this problem, again, I notice I have two terms with variables, so I can move everything to one side because one of those powers of 1/2 and the other power is double that, so this is quadratic type. So if I move everything to one side, I'll subtract a 5 from both sides, and I can use u substitution, letting u be my smaller power, root x, which means u squared will be double that power or just x. So I can type in or substitute in 2u squared plus 9u minus 5 equals 0. So here my leading coefficient constant are both prime numbers, so I know that the product of the first terms has to be 2u squared, so 2u and u is it. My product of the last terms is -5, so I have to have a positive and a negative number. They have to be 1 and 5, either positive plus or minus 1 or plus or minus 5. And the outer plus inners have to add up to 9. So I know my positives need to be much larger, so I'll put my positive 5 here. So my outer product is 10u. My inner product will be minus 1u, which does give me my sum 9u. Therefore, I can solve for u. I take the opposite of my constant, positive 1, divided by my leading coefficient 1/2. And when I substitute this back in, square root of x is equal to 1/2. Square both sides to get my x value. 1 squared over 2 squared is one solution. Here u is equal to -5. When I substitute that in, root x equals -5. This is inconsistent. It's an extraneous solution that's not going to work, so my only solution is 1/4. Now, I could have also solved this problem using a radical. So if I isolated my radical here by subtracting 2x from both sides, I can eliminate the radical by squaring both sides, giving me 9 squared, which is 81x, equals, and then I can distribute through or expand here. 5 squared is 25. Double the product of these. 5 times a -2x is -10x. Double that gives me -20x. And then square my last term plus 4x squared. So if I was solving this, I would wind up with 4x squared, subtracting 81x from both sides. It's giving me -101x, then plus 25. And when I look at solving this, I do notice that my outer and inner products here, 4 times 25 is 100. And 100, if I rewrite my middle term here, the two factors of 100 whose sum is -101 is -1 and -100. So if I rewrite my middle term as the sum of those, drop down my first and last terms and factor by grouping, I can remove a common factor of x from my first pair of terms, leaving 4x minus 1. From my second pair of terms, I can remove a common factor of -25, leaving 4x minus 1. And my common factor, binomial factor of 4x minus 1 can be removed, leaving factors x and minus 25 as the terms of my other binomial factor. Now I can set each of these factors equal to 0. I get x is equal to the opposite of my constant divided by my leading coefficient. And here x is equal to 25. Now I do have to plug these back in because I was dealing with a radical problem. When I plug it back in, I get 9. If I plug it into the original form up here, I get 2 times 1/4, which is 2/4, plus 9 over the square root of 1/4 is 1/2, 9/2. And I want to see, is that equal to 5? Well, 9/2 is 18/4. 18 plus 2 gives me 20/4, which is equal to 5, so that one checks. Do the same thing with 25. 2 times 25 is 50, plus 9 times root 25. I can already tell right here, 50 plus something is not going to equal a 5, so that will be an extraneous solution.